You know, for over a century, industrial chemistry has built our modern world. I mean, everything from medicines to the materials in our homes. But let's be honest, it's often come at a pretty steep environmental cost. Today, we're going to look at a revolution that's happening at the molecular level, a way to make everything we need without all the hazardous waste and pollution. This is a story of green chemistry and what's being called the enzyme economy.
And that really is the big question, isn't it? What if we could copy nature's own playbook to power our industries? What if our factories could run with the same quiet efficiency as a living cell? I know, it sounds a little like science fiction, but as you're about to see, it is very quickly becoming our reality. Okay, so let's start with the core concept. We're talking about a massive shift in how we think about making things, a true green revolution for the chemical industry. Now, what's so important about this definition from the EPA is that one little word, design. See, this isn't about cleaning up pollution after you've already made a mess. Nope. This is about being smart from the very beginning, preventing that mess from ever being created in the first place. It's a proactive, just a much more intelligent way to do things. And this slide, wow, it just lays it out perfectly. On the left, you've got the old school way. Make your product and then figure out what to do with the toxic sludge and waste afterwards. That's the end of pipe method. It's inefficient, it's expensive, and it's dirty. But on the right, you have the green chemistry approach. Design the whole process to be clean from the start. Use way less energy, work at normal temperatures, and create almost zero waste. It's a total game changer. So think of these as the golden rules. The goal is pretty straightforward. Just be smarter. Stop waste before it starts, run reactions at room temperature instead of boiling them with tons of energy, use safe materials that we can grow again. And the real key, the thing that makes all of this possible, it's that last point, catalysis, finding the perfect catalyst to do the heavy lifting cleanly and efficiently. Which brings us perfectly to our next big idea, because, well, it turns out nature solved this exact problem billions of years ago. It created the perfect catalysts, these incredible, tiny biological engines that basically run the entire living world. And here they are, these microscopic powerhouses, often just taken from simple microorganisms. They are the real heroes of our story. I mean, these things are nature's ultimate specialists, evolved over eons to do very specific jobs with unbelievable speed and precision. So the most important phrase there is mild conditions. You know, traditional industrial chemistry is all about brute force, high heat, intense pressure, harsh solvents. But enzymes, they get the job done at room temperature, in water. They are the ultimate green machines. So how do they work? The best way to think about it is like a super advanced lock and key. An enzyme is incredibly picky. It will only connect with one specific molecule, its substrate. And once it finds it, it morphs to create this perfect, snug fit, performs one single, super clean chemical reaction, and then lets go of the finished product. That specificity, that's its superpower. And when you add it all up, the advantages are just undeniable. You save a ton of energy because they're so selective. You don't get all those unwanted, toxic side products you have to clean up later. And when their job is done, they just biodegrade. It's a perfectly circular and sustainable system. Okay, so this isn't just some cool science experiment happening in a lab. This is a massive, and I mean massively growing business. Let's take a look at the economic engine behind these tiny biological engines. I mean, just take a look at these numbers. The global market was already over $7 billion in 2023, and it is set to blow past $10 billion in just a few years. This is solid proof that sustainability isn't just some nice environmental goal, it's a major economic driver. And what's so cool here is how versatile these things are. This isn't a one-trick pony. We've got different types of enzymes for pretty much every industrial need you can think of. From making your laundry detergent work better in cold water to producing life-saving drugs and even creating biofuels, enzymes are becoming absolutely essential tools across the board. All right, let's get specific. Let's look at a real-world case study to see how this works. Edoxaban is a really important blood thinner. Now, making it the old way was a complicated, messy process with a lot of harsh chemicals. But what happens when you bring an enzyme into the picture? This is the result. A mind-blowing 90% reduction in the use of nasty organic solvents. Not only that, the process cut raw material costs in half and made the whole manufacturing process way simpler. This is green chemistry in action, better for the planet and a whole lot better for the bottom line. Okay, so we've seen the science, we've seen the huge global market. Now let's zoom in on one specific region that is betting big on this technology, the state of Gujarat in India.
What you're seeing here is the government actively betting on this technology for its future. Through big initiatives like their Vibrant Gujarat Summit, they are positioning the state to become a world leader in industrial biotech, with a special focus on making these enzymes. They can see which way the wind is blowing.
So why Gujarat? What makes it the perfect spot? Well, because it's already an industrial powerhouse. It has a massive manufacturing base in the exact industries. We're talking pharmaceuticals, textiles, food processing that are ready to use this enzyme technology right now. The infrastructure and the demand, they're already there.
And here's the most important part. They've got the people. A skilled workforce that's ready to shift from traditional manufacturing to the high-tech, bio-based industries of tomorrow. So this isn't about starting from scratch, it's about retooling an already powerful economic engine for the future. So where does all this go from here? Well, this technology is not standing still. In fact, the next steps look even more revolutionary.
And this is where things get really, really interesting. We are now starting to merge the incredible power of biology with the intelligence of AI. We're not just finding useful enzymes out in nature anymore. Now, we're starting to design them ourselves. Right now, scientists are basically engineering enzymes to be tougher, to work in even more conditions, and to last longer so you can reuse them. And by using AI, they can predict and design brand new enzymes for custom jobs in a tiny fraction of the time it used to take. This is just massively accelerating the pace of innovation. And really, this is the big takeaway from all of this. For decades, being green was often seen as just a cost of doing business, an extra box to check. What enzymes and green chemistry are proving, without a doubt, is that sustainability is the competitive advantage. It's the smartest path to a more efficient, more innovative, and more profitable future. So I'll just leave you with this one final thought. The 20th century was really defined by our mastery of chemistry, for good and for bad. The 21st century, it might just be defined by our ability to partner with biology, to work with nature's own code, to build a cleaner, smarter, and truly sustainable world. And what will that world look like? Well, that's what we're all about to find out.